Hello guys and welcome to TechMasterminds meetup. My name is Kate.
And my name is Oksana.
We are really happy to have all of you here on our first TechMasterminds event during this year. We have attendees from all over the globe, like Latin America, US, Portugal, Poland, Bulgaria, Ukraine, and many, many more. Thank you guys for joining and your interest in our initiative.
TechMasterminds is a series of webinars where we invite people from top tech companies and they spread their knowledge. This is our monthly webinar, so subscribe our channel and don't miss our next events.
And actually, this series of tech events organized by Sigma Software, a global IT consulting company with offices all over the globe and with well-known clients like Volvo, AstraZeneca, Danet, and many, many more. If you're interested in joining our projects and exploring new opportunities, just check our career website. That will be just in a few moments in the comment field.
So today we are joined by Anton, software development engineer at Amazon Web Services. Anton, hello. Do you hear us?
Yeah. Hello.
Awesome.
Hi from Sydney.
How are you?
Yeah, I'm good. Glad to be here.
So it's the middle of the day in Europe and it's almost the end of the day in Australia. How was your day? What did you do?
Yeah, it was an awesome day. I had a chance to work today with Bedrock, our generative AI capabilities at AWS, exploring that for our customers. So I would say it was quite productive and interesting.
Awesome. Can you tell us a bit more about yourself and about your career path? How did it start?
Sure. So I started my career path like 15 years ago, approximately. From Ukraine. I worked on several projects in several different companies in Ukraine. Then I joined one of the US companies, working there as an engineering manager, and come back to another Ukrainian company to lead a solution group in there. And then my life 3 years ago dropped me here in Australia, and now I am in Sydney.
Thank you so much. Do you prefer more flexibility or structure in your work?
Yeah, I do prefer structure in my work. However, the work that I'm doing right now, it's demonstrating art of the possible for a customer working with emerging technology in a domain with capabilities and tasks that no one solved yet. That's why it's pretty hard to be strict in there. So there are a lot of different things that you need to think about, and you can't be organized, but it's fun.
Thank you. Are you more detailed oriented or big picture focused?
Yeah, I used to be a big picture focused, but with AWS, as you know, we have our leadership principle, and one of them is dive deep. So without that, you can't survive. So that's why now I'm focusing into details. This is a part of AWS culture.
Is it hard for you to change your mind?
It's quite tricky. You need to constantly learn new things, see how other people do a job and learn from them. It's challenging, yeah, but it's fun.
I see. So I have just 2 more questions. Do you like to take risks in your work, daily work?
I would like to say that I do, but I don't. Yeah. Working in a big company with a global representation, it requires you to be very careful in what you're doing, saying, because the impact is global and massive, and so the risks are.
Mm-hmm. Yeah, that's true. And the last one, do you enjoy to spread your knowledge?
Oh, absolutely. Yeah, that's the one thing that I like, and I think I'm lucky enough such an opportunities. That's why I'm really happy to be here and share my knowledge with all of you guys. Yeah, I think it would be an amazing journey.
Awesome.
Cool.
Then I think we are ready to start.
Yeah, I just want to remind our attendees that we will have Q&A session with Anton, and if you have any questions during the speech, just put all of them in the comment field, and we will answer all of them just, I think, in 30 or 40 minutes. So, Anton, I wish you good luck. I wish you a pleasant audience, a lot of questions, and enjoy. See you soon.
See you soon. Enjoy.
Thank you. Oh. So, I will give it a second to load the screen. Yeah, amazing. I can see myself now. So welcome, guys. It's an exciting opportunity for me to talk for community here. And I would like to share my knowledge about what we do, how we do some stuff without going into details or proprietary technologies, but just give you a big picture what can be done, how the stuff is going on at AWS. So my topic for today is to talk about the energy asset integrity and machine learning, how to combine these two things in a modern world and solve the real customer challenges. I think we go through this part yet already, but here is some my career path. So I worked with several different companies across my career in a different position, starting from a software developer, switching to software engineering manager, doing some pre-sales work and leading solution group. And also my current role is a software engineer at Amazon Web Services. And this is what is happening in my life right now. I spend some time with my kids, and also I like to take photos with the kangaroos. This is an exciting opportunity to be in Australia, so I really am able to do that in here. Cool. So let's jump into some serious stuff now. So what do we do? I'm a part of a public sector at AWS, and our mission is to demonstrate the art of the possible to accelerate the public sector customer journey to the cloud. So it's usually require a focus into AI, ML, data lakes, edge computing, robotics, etc. And several engagement that we work on was a robotic command and control center, detection of illegal activities from video streams using machine learning, working on disaster relief situations, and so on. Usually we do a proof of concepts for our public sector customers, and it takes us around 10 development weeks to achieve that. Let's talk about the problem that I'm going to present you today. One of the projects I'm working on is for the customers that deliver electricity across states through 2 million overhead assets connecting around 3 million customers spreading across the geographically dispersed area. So you can see on the map how big the Australia is, and so how much you need to cover. So the customer is seeking avenues to leverage technology to advance their capabilities in monitoring the condition of a network components to provide safe, economically efficient delivery of energy across the country. What does it mean in a real life? So we have a pole that have several different components on it. And what we want to do is to take a look into it and evaluate its health status and to say, okay, probably this component needs to be replaced or this component will go out of order in some X days, etc. So this is what was this task about. We need to take a look into that in a scale of a millions assets and identify if it's good or bad, if it's working or not. My first thought was, thanks God it's not a Thailand engagement. Otherwise, I mean, we need to stop right now. There is no possibility to do that with the technology. But we are lucky to be in Australia now, so we're good. Now, how to approach this problem? Of course, you can send a human to do evaluation of each asset on each pole. But even with the 2 million poles, take a look for 15 minutes into each of them. It will take us approximately 60 years, working 24/7. So this is not an answer, so solution, because it's too complex, too big. Wait for a complaint. Yeah, some countries do that. I don't think it's a right answer to a problem now. So, of course, we need to approach that with the technology. How we can do it? We can grab some inputs like photo, video, or LiDAR data and analyze it. So for photo data, we can fly with a drone on top of energy line and make photos of individual poles, or make a video and then analyze it after all. Or we can use the LiDAR technology. This is a light detection and ranging. So it's a sensor method that's used to examine the surface of the Earth. And it's usually used in self-driving cars, but it's not limited to that technology. So what we thought would be, it will be really nice to go with either drones or fleet of vehicles across the country, making photo, videos, or LiDAR data, and then consolidate that. And by the way, when I'm talking about that, it's like not a hypothetical situation. So this is something that is already happening, and it's done by several different companies. They're in a different time in their journey, but this is a journey that's already going on. So now we identify that, okay, this is a technology problem, and the solution should be related to technology also. And then we decide, okay, what do we want to show for our customer? We want for customer to be able to drive the business decision out from this solution. So we want to show them a map, and on a map, we want to visually present each pole and each asset on it with a color representing the health status and what is going on it. So then the person can dive deep into that, understand it, and make business decisions. This is what we want to achieve and achieved in the end. And when you look into a map, you can scroll through it. It will scroll. The new points will appear or disappear based on your location. And then you can also do queries. For example, I want to take a look into all my energy grid and find out where is the wooden poles are. Maybe I have a campaign to replace every wooden pole with concrete or steel pole. Or what is my asset that had a P2 defects in the last year? Maybe I need to see if there is some area where all the defects are concentrated and I can go and replace the whole line. So there are several different options how to approach that, how to drive a business decision from that. But let's focus now on the technology side of the thing. So what we want to go through is two stages. First one is pre-processing. This pre-processing includes machine learning in it, and it contains several steps like collecting data, training model, and retrain them periodically to get better results. And processing. So we will receive an image or video or LiDAR data, identify assets on it, identify health of these assets, and reflect it on a map. This is our solution architecture diagram that we work. It's not full, but it contains the key components for you to understand where we stand and which AWS technology we use. So I will start with the yellow on the bottom, which is an ingestion layer. So with an ingestion layer, we took all the incoming data, photo, videos, LiDAR, put it into S3 buckets, and then we train several models based on that data. First, we need to segment them, and then we need to train them, and I will show you that a bit later. After that, when model is trained and run, we throw a new file that we want to identify a health. It goes through all these models, getting their health status or results, and then it goes to Amazon API Gateway Service endpoint, and to Lambda, to DynamoDB, Kinesis data streams, and at the end of the day, it will land in Amazon Open Search Service. We use Amazon Open Search Service because it's a good technology. It gives us an opportunity to have a fine-grained permissions, which I'm going to talk later, and it's a good for search capabilities. Let's know all classes of these technologies. But we, as a part of design sessions for that, did evaluations through several different technologies, databases, and approaches, and stop with Amazon Open Search. Then, when this data is processed and exists in Amazon Open Search, we go from the left side, which is this blue box, and this blue box is a web layer. We go through AWS Web Application Firewall to protect our customer through API Gateway and AWS Lambda backend. We do not use Docker containers or any other type of Dockerized technology here. We store our code, the whole code for a backend. We usually do a serverless in Lambdas. So it will be cheap for customer, cheap in development, scalable, and so on. And also we host our website content in S3 bucket. It's a static website connecting through the API gateway to all our backend systems. For map visualization, we use Amazon Location Service, and for authorization and authentication, we use Amazon Cognito user pools. Let's jump into pre-processing first. So pre-processing is a process of collecting initial data, train models, and be able to retrain them periodically. What helps us to achieve that is Amazon SageMaker. Amazon SageMaker we use to train our machine learning models. For that, you need a large, high-quality labeled data set. And Amazon SageMaker ground truths help you to build high-quality training data sets for your machine learning models. So how does it work? Let's start with a simple thing. Let's start with an image classification. We have 4 different options how to create a labeled data set out from images. We can use image classification, a single label. We can use multi-label. We can use bounding boxes or a semantic segmentation. Each of these approaches has its own unique strengths and weakness. I will show you today bounding boxes and semantic segmentation as the 2 approaches we evaluated during the prototype. First one, we need a data set. For the data set, we use a set of photos. It's done on my personal iPhone, so we're good with that in terms of copyrights. Now, what you can do is to make a bounding boxes on top of an object. So I use a green color to identify what the pole is, purple to identify the light, and brown to identify transformers or some type of an asset that exists on the pole. And you can label this data set and train your model of that. This is one approach. Second approach, which is a bit more complex but gives a real good value, is a semantic segmentation approach. So the worker needs to draw pixel level based labels around specific objects and segment it into your image. As on a picture, you can see that This one is segmented as a car with a blue color, and the girl is colored with red. How does it happen in reality? In reality, you can create a semantic segmentation job with a labeling tool. You provide a task, you provide a picture, and you set labels over here. You can add up to 10 labels. And for example, here we didn't use that exact labels in our prototypes, but for this example, I'm showing you we can do all wood, right? Light, asset transformer, and asset light. This is for labels that we want a person to go and label image with. Also, we can provide here a good example, bad example, and so to drive a quality. For an end worker, it looks like that. It go into UI, it see a picture, it can select what label is it working on, for example, all wood, and go and color the wood pole with a green light. And this is how labeling is going. And then they go and select a light and go and color it with a blue over here. When everything is done as a part of this task, you click on the submit button and this picture is labeled. Then there are several techniques how to improve the quality of that. You can give the same task for several different people and ask them to label it, and then to take a look what is the best, but it's like a separate topic. So let's focus here that we label this. Now we have a labeled picture by a worker. How would you do that? You identify a class map. It's done automatically. You don't need to do anything, but as far we have a bit of deep dive here, I'll show you a JSON file. You identify a class map to say that class 1 is a pole street, class 2 is a set light, class 3 is a set transformer. And here, when the prediction is happening, we can see that on this picture, ML model identified an asset of a class 0. All right, let's go with a class 2 with a 32% confidence and within this bounding box. So the first number is a class map. The second number is percentage of its accuracy. And the last 4 is a bounding box across the image. Cool. Now we did a job of semantic segmentation for an image. We can do the same job for our point cloud segmentation, which is working with LiDAR data. For this also, Amazon Ground Truth give you an opportunity to create a job, assign to a worker, and label it. And this is like a small video how it looks in the real life. So you see the LiDAR data, the raw one. Also, you can have several cameras on the right to be able to better label it, to see it from a video point of view, not only from a dotted point of view. Then you go and adjust it a bit. And when your job is done, you click on a submit button. So the tool see that this job is done and can go into a next task. Now we have labeled point and cloud also. Let's talk about workforce management. So who is doing this job? We know how to do it, but who is actually doing that? And there are at least 3 options you can use that's available in Amazon SageMaker. It's a Mechanic Turk workforce. It's an Amazon Mechanic Turk workforce. It's the one that you can just pay money and they will do a job for you. You don't know who they are. It's like an outsourcing. You can create a vendor managed workforce. It's whenever you have your own set of teams, but you want to give them kind of separate tasks. And you can create your own private workforce to label or review a data set. It's when you have like one internal team, you are happy to give them this task to do. So you go, click, and create that. And now the next problem we faced is how are we going to distribute this load? How we're going to distribute these tasks to a different group of people? And here also we use points and coordinates. And we say here that whatever is go inside of these coordinates, 151.24, blah, 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 is go into CQOD workforce. And the other one is going to NQOD. And this is how, based on the coordinates, we assign the job to a proper team to label it. Because it can happen that one team know this location the best. They saw these images like this posed by their eyes, so they can compare it and provide a better output than others. Of course, nothing is happening without the challenges, and there are several different limitations working with Amazon SageMaker ground truth. First one is labeling job can be just a labeling job or can be a streaming labeling job. And there are several limitations like how much days you can keep job alive, how much active tasks you can keep at the same time here, what is happening when this expires, etc., etc., etc. And as far our journey was to go through the country, collect the terabytes of data, throw them into S3 and process. So the whole labeling part of this exercise can take like weeks or months. We don't want to go into this bottleneck. So we carefully evaluate each of the possible bottleneck and build like a solution to overcome that. I'll skip that part, but you should know it's not very easy. And going out of the box, you still need to get some effort to align technology to your business needs. Now let's talk a bit about MLOps. MLOps is machine learning operations, and it's a ML culture and practice that unifies ML applications development with ML system deployment and operations. And several advantages of MLOps doing that in this way to train model is you can keep the code of your models under version control with all the good stuff that's going with the version control, like a pull request, code reviews, code collaboration history. You able to co-collaborate with your team. So several data science can work on the same model at the same time. And each ML engineer can have their own development environment and try to create the better model, evaluate it against several metrics, and then drive the perfect outcome from this model. Yep. So these are the key benefits of MLOps, and we use MLOps approach to train model in our journey. What is MLOps state of an art for today? There are several different technologies in Amazon that is a state of an art for today, or you can choose from. You can go with Amazon SageMaker Canvas. This is a no-code environment to train your model and deploy it. You can go with Amazon with Autopilot ML APIs. You can go with Jumpstart notebooks to manually train with the step functions. And the bad stuff is that it's changed once per quarter. Whatever I'm telling you now might be not the state of an art in 2 months or 3 months. The technology in this area evolves rapidly. We choose to go with Amazon SageMaker Jumpstart. And here is how it looked in the end. It's a bit complex. I'm not going to overload you with all the details. If you're interested in this topic, you can take a look You can stop this video, take a look into it, and try to deep dive into details. But basically, what we were able to achieve here is that creation of a model was isolated as a part of a service catalog product. So every data science engineer can go into service catalog and say, I want to start working on top of some work, on top of that product. They will get their own development environment with code commit and code build capabilities. And they will be able to work there, do all the job, push into repository, etc. When they are happy with the results, they push the code. It starts the Amazon SageMaker training job. It's train a model and put it into Amazon SageMaker model registry. Then what is happening, you can see all the models and their metrics like mean square error and other one which is defined in this machine learning notebook that you're working on. So whenever you identify that some model evaluate better than another, you can improve it, and this model will be propagated as a main model for this specific use case. Cool. I know it's a bit tough to get all this information through, so don't worry about that. You can always refer that back, and you can always read a bit more, or you can compare to your own company practices here and see which one works for you. So the next part of this is a processing. So how we're going to receive this image and how we're going to evaluate it through the model. Until this time, we collected images, we do a semantic segmentation of top of that, created a labeled data set, images and labels, and train the models via MLOps. Now we have a set of trained models and we need to start to utilize them. So here we are going to receive an image, identify an assets on the image, like here is a pole, here is a light, here is a transformers. For each of them, we are cropping this image and running a separate machine learning model that we trained that know how to evaluate a house of this particular image. And then we put that data on the map. And it's really orchestrated with some complex step functions, which I'm not going to dive deep into, but there is several points, several small items that we do here. For example, we start with extracting metadata to take a geospatial data from an images and compare that for a master data in our system. So we are able to identify with which pole we are working on. And then we can go and crop images, run through several different models, evaluate it, house, and save them back into API gateway and eventually into Amazon OpenSearch. Let's talk a bit about why did we choose Amazon OpenSearch. We need to be able to do queries to the data to select wooden poles or poles with P1, P2s that I showed you in the beginning of this presentation. And the optimal way to do it with an Amazon OpenSearch, as well as it complements itself with the security features to restrict access. I'm going to talk through several of them right now. We use the field level security and the document level security. With the document level security, you can restrict an access to a certain document to a certain group of users, to users or groups. With a field level security, you can hide some columns from a certain individuals. For example, let's assume you're working in the space of medical or finance and you don't want to return your card number or your medical health card. So you can say that, okay, return me all the line, but excludes this particular columns from it for a set of users. And this is called a document level and field level security in OpenSearch. And it looks like that. So we say that if the owner name is company one, then it's allowed to do a CRUD request to some specific index patterns. And it's applied to IAM role. And this IAM role is something that user will assume when they will log into the system. It's also a bit complex, but it's a powerful way of keeping your permissions under the control and to ensure that only the right set of people will get the right set of data. Now we run images through the model, identify health, if it's healthy or not healthy, and we put that data into OpenSearch. The next step is to put them on a map. And for that, we go through evaluating several different technologies and approaches and libraries and come up with a top 5 which we want to try. We did some spikes on them, and our final decision was to go with MapLibre. And here is some reasoning on the top of a screen. You can go through. It's a well-funded project, top engineers working on that. It have a good benchmarks in terms of a performance, and you can see that it's actively maintained. So it's one of the reasoning we used it. Cool. So as a result, what's happening, like a big picture? You as a worker travel through the country, run a drone on top of your power line. It makes videos or photos. Then these photos goes to a S3 bucket, and you go and label them. You label them, you train machine learning models to be able to identify them. And also you train a machine learning models to identify a health of each individual asset. When this job is done, you save these models and you start receiving the real files. Now the real images come in and goes through evaluation of the different models. It gets what it is, it gets its health status, and then it throws itself into Amazon OpenSearch and go into a map. This is how it looks. This is a small slide to keep your attention alive, and I promise it will be 2 to 3 more slides with the hardcode stuff, and then we'll finish that. Yeah, so just wait for it. Several technical details that I want to mention, and it's more like an approach that we use and what we like, but we use a single table approach in DynamoDB. It's whenever we store all the data of our application in one table. You see that it have different set of fields, different columns, different types in it, and even JSON in some of them, but utilizing DynamoDB keys and also secondary indexes, you're able to query this data quickly and efficiently, and you have it all in one place. This approach might sound a bit strange, but it's battlefield proved. It's used in lots of different companies at Amazon Web Services, at Facebook, etc. So this is the approach we like and use in our prototypes. And the last one is a permission boundary. Permission boundary is an advanced security feature that we use for our prototypes. This is a way to limit user access to an application and limit a possibility to do harm. So let me say, to be a bit more strict, so it's a set of maximum things a principal can do. And we define very explicitly about what principal can do. Let me give you some examples so you'll understand it better. on top of our standard roles, we have a permission boundaries. And these permission boundaries are saying that, okay, you can do whatever with AM permissions, but only if this resource tags with my customer, for example. So in this way, your solution will have an access only to resources that you created that tagged with your tags, but will not have an access to other resources in your AWS account, even you mix up several different services all in one. And here is several other stuff. So we mostly care about IAM permissions. That's why we crafted that very carefully. And we say that you can create roles only if you attach permission boundaries into that. In this case, this will help us to fight a problem when I, as a user, can just create a new role, give it permission, whatever I want to mine Bitcoins, for example, and run that. And this is blow up your customer's bill. So this is a way for you to protect it. This is a good security practice. It's a bit advanced, but it's worth it. I will leave you here. If you're interested in these permission boundaries, you can go take a look and evaluate if it's a right fit for your project. And on this, I will end and say thank you.
Anton.
And I'm going to take a look into a chat. Yeah.
Yeah, do you hear me?
Yeah, I do.
Yeah. Thank you so much for your speech. I have the first question. Can I be
Absolutely
on front of, yeah? So how do you collect the data from the places where you have a lot of buildings and trees and it's not allowed to use drones?
Yeah, so as I told, there are several different approaches to do that. You can go with just your phone and a camera and just make a picture from a right angle. Also, you can ride a car with this LiDAR technology, so it will go through the shape and you can identify where the pole is. But yes, absolutely, you can't, there is no one-size-fits-all approach to this problem. So you need to be creative, and this is something that companies do.
Sounds like a lot of work, actually.
That's true. That's true. I told you it's 60 years. So if we will go one by one by a manpower 24/7. So it's really a lot of work. That's why we need technology.
Mm-hmm. Yeah, you're right.
Yeah, Anton, I also have a question from myself, if you don't mind. You worked previously in the smaller company and then switched to the really well-known brand like Amazon. Do you have any switch in your mindset too? Like what, like some insights that you got from working for a well-known brand?
Mm-hmm. Yeah, it's definitely a big change. So I used to work in a smaller companies when I know lots of people and we can directly influence how the company live and how the customer feel about us. Working in Amazon, I don't know how millions of people are there, but you feel quite small, but you need to do your job perfectly so that whole mechanism will roll, go, and deliver what it is right now. And in terms of a mindset, yeah, Amazon is very well known about its unique culture and leadership principles. We use them really a lot in our daily life. We argue with them, we back up our decision with them, and it's something that you need to learn to succeed in there. How to make these decisions, how Amazon do some decisions, what do they write, how do they talk, how do they structure meetings, etc. And all that's definitely shift your mindset. I'm really happy to have both of this experience so I can compare pros and cons and try to bring my unique way of doing things to Amazon. but also I do understand that Amazon is a well-known company, goes through like decades, and they have their own way that succeed. So I need to comply to that. And it's a matter of balance how you do that.
Okay, cool. Thanks. I think we have a couple of questions. Guys, I want to encourage you to take the opportunity and ask your question directly to our speaker. And the first question will be from Yaroslav Mota. Does anyone need to operate the drone, or is it self-flying?
Yeah, in this particular case, it's more like a customer decision how they're going to do that in the real life. But I think we need to start small, step by step. So you need first an operator to run it, right? Because the problem that you can face is, what if the image that you will do will be from the angle that will hide something, right? And so you will take a look into a pole and there should be a street light on it, but it doesn't. Does it mean that picture is bad, or does it mean your model is bad? So this is a tricky stuff that is still on the journey. But yeah, currently start small. So there will be a person who flies a drone.
Okay, cool, thanks. Next question is from Maxim. Do you have any plan on using Gen AI for learning data preparation, labeling instead of manual work?
So we currently work on a different project with a Gen AI, which is very exciting. And I hope one day I will be able to share with you our journey with generative AI. But currently, I think what is happening here, what the customer want to achieve is over time, the system will do this labeling itself. It's not a Gen AI, but it's with machine learning. The system will label itself, segment itself, and kind of go to train a model. Then when model will be trained, it separates data into training, validation data sets, and it will evaluate it and get with some metrics how accurate the model is. And if the model is good, it can propagate it further. So whenever this shift will happen and the segmentation will be done by machine learning, then we can see, will the new models will succeed or will fail? But there is definitely a plan to do that with machine learning.
Thanks. The next question, we have 3 questions from Christoph. Do you have sample that could you share? Or
what do you mean by sample? Sample of
Christoph, please
data?
Clarify what you mean by sample. And another question, if the presentation will be shared or not. Yes, sure. After the meetup, we will share the recording and presentation as well. How did you access data from photo to know if it's good shape or bad, and percent of used?
So I'm not 100% understand your question. I'll try to answer as I can, and you can clarify in chat. So we get the photos, right? And then a human is doing a segmentation. There is also an opportunity to send the same job, so the same image, to several different people. So every one of them will do segmentation, and then the system will decide which one is better. Or you can train on, I think it will not decide what is better, but you will train on all of them. And this is how you get a better coverage. This is how you try to protect you from a human mistake in the loop. What percentage of use?
I think Christoph will.
Yeah. Okay. I will a bit elaborate on that. So I think one of the way that we evaluate the data from a photo to know if it's good or bad is we run it through the first model. We extract coordinates from it, and then we go into our system where all the records are storing and say, like, give me the pole by these coordinates, and we get it back. Let's say it's ID 123. And now we know from the system that there should be a street light, there should be 2 transformers on it, and it should be a wooden pole. Now the first model that do asset evaluation, it will take a look into a photo and it will say, okay, I found wooden pole, I found the light, and I found the one asset, one transformer. It compares it to our master data set and sees there is a discrepancy. So here is 1 transformer and here is 2. Then it's go to a manual loop for a person to verify what's going on with this photo. But if it's able to identify everything, then we say, okay, this is a tick. This is a good photo, and it can go to a labeling.
Thanks. What is the check for all Amazon services that you use in the project?
Not sure I do understand what the check mean.
Like,
I try to answer as I can, but Oksana, you can clarify a bit in the chat. So whenever we do a design document for these prototypes, we go through each service, take a look, are they available in a region? Are they solving a task? What their limits are? For example, with SQSQ, you can process, I'll just randomly generate a number. So you can process 1 million records per second. If it's not enough, then you need to switch into Kinesis data streams, and it have a higher limit. So this is a type of evaluation on the services that we do, because as we work with a high load and lots of data, all these things are matter. You can't just select the first technology you like. You really need to evaluate each service limit. And also you need to understand if there's adjustable service limit or not. Can you request more throughput? Or it's a hard limit and then you need to choose another service or work around it somehow.
So the question was about the bill. How much does it cost for you to use all the Amazon services in that project?
I'm sorry, I will not be able to share this information. This is confidential.
Okay, and we have also one more question from Evgeny. How long did it take to produce a prototype from ideation to ready-to-use prototype? If you could share such numbers.
Yeah, I shared it on the beginning of the presentation on the second slide. We work on the cycles of 10 development weeks. This project took us a bit longer, but it's like around 12 to 13 development weeks. And before that, we used to do a design document for several weeks, and then security, handover documentation, and some other stuff in that. So the whole duration of this project was around 20 weeks with 12 weeks of development cycles. For a small group of individuals, this is like 2 to 3 to 4 person.
Okay, thanks. I think we covered all the questions, and I would like to say thank you guys for your involvement, for all who joined us, for our amazing speaker and my partner in crime today.
Thank you so much, guys. It was a pleasure to present to you today. I hope you learned something new, take a look, see what you can use, whatever fits into your company, and good luck. Have fun.
Thank you. Just a few reminders. So we are in our Lviv office at Sigma Software. We are in Ukraine. Glory to Ukraine. Thank you again, Anton Vasilenko, for your time. Thank you for being with us today. My name is Oksana, and this is Kate.
Yeah, guys, I want just also to remind you that you will get all the presentation, all the slides, and recorded from our today's webinar, so you can review, take notes, and use this case as experience in your company. I wish you good luck and hope to see you on our next events. Bye.
Thank you. Bye.